Welcome to Homework Lib.
So over here we're going to have a 128.7 gram sample of an unknown substance, which has the molecular mass of 189.5 grams per mole. We know that it's going to be cooled from 233 to 147.6 degrees Celsius. We're given the heat capacities and the delta H of vaporization for this compound, and we're told that the normal boiling point is going to be 160.3 degrees Celsius. So over here, the processes that we're going to have is going to be, first of all, cooling up the gas. This is going to happen from going from an initial temperature equal to 233 degrees Celsius up to a final temperature equal to the boiling point, which is 160.3 degrees Celsius. Next up, we're going to have the condensation process. Remember that the delta H of condensation is going to be equal to minus delta H of vaporization because it is going to be the inverse process of that. And next up, we're going to have cooling the liquid from an initial temperature of 160.3 degrees Celsius up the way to a final temperature equal to 147.6 degrees Celsius, like this. So for each of the processes, we're going to have a value for delta T. Notice that the delta T is going to be negative. So for the cooling of the gas and for the cooling of the liquid, the values for delta T are going to be respectively equal to minus 72.7 degrees Celsius and minus 12.7 degrees Celsius. So over here, the heat is going to have, as I mentioned, three different processes. I'm going to put in red the first one, in purple the condensation process, and on green the last one. So the heat is going to be equal to, the first process is going to be mass of substance times the heat capacity of the vapor or of the gas times delta T for the gas. Next up, we're going to have the condensation process, which is going to be equal to minus N because the delta H of vaporization is given in kilojoules per mole. We're going to need to transform this into joules per mole to add all of the quantities appropriately. So this is going to be equal to minus amount of mole, or alternatively, since we know that amount of mole is going to be equal to mass divided by molecular weight, we can put this factor as mass divided by molar mass times delta H of vaporization. Over here, all with the negative sign. And the last process is going to be equal to mass times heat capacity of the liquid times delta T for the liquid. Remember that here I added the minus sign in the delta H of vaporization because we're considering the condensation process, which is going to be the inverse. So replacing over here the values, let me put here some space. The value for Q is going to be equal to 128.7 grams of the substance times heat capacity of the gas, which is 1.04 joule per gram degree Celsius, times delta T for the gas, which is minus 72.7 degrees Celsius, minus mass divided by molecular weight, 128.7 grams, divided by the molar mass, which is 189.5 grams per mole, multiplied by the delta H of vaporization, which is going to be 78,110 joules per mole. And the final part is going to be plus the mass times 128.7 grams. That is going to multiply the heat capacity of the liquid, which is 1.62 joules per gram degree Celsius. And finally, the delta T for the liquid, which is minus 12.7 degrees Celsius. Notice that in this case, since we are going to be absorbing heat from the environment, since we are going to be releasing heat to the environment, the sign for Q is going to be negative. So let's cancel out the units, grams with grams, degrees Celsius with degrees Celsius. grams with grams, mole to the minus 1 with mole, grams with grams, degrees Celsius with degrees Celsius. And with this, the value for Q is going to be equal to minus 65,427.5 joules, which is the same as minus 65.43 kilojoules. You can run it off as 65.427, but in this case, since the limiting factor is going to be 4 significant digits in all of the calculations that we have, then this is going to be the correct result. Oh, sorry, actually it is 3 significant digits. The heat capacities only have 3 significant digits. So the result would be minus 65.4 kilojoules. So that is just going to depend on how strict is your professor on that. Just be mindful of that. And with that, it would be all. Thank you very much and have a good one.